Okay, it looks like I'm recording, so I have to record this, but today I'm really excited because this is the first time I've ever gotten to teach a lesson to kids. I used to teach grown-ups how to do CPR, but it's a whole lot different teaching grown-ups than it is teaching kids. So this is a new experience for me, and hopefully it will be an enjoyable experience for you. I have some handouts that I'm going to pass out. Did I give you those handouts? And did you get your pen?
I didn't take them off. Thank you, Josh.
Now, while I'm handing these out, you remember that Miss Parsons has been teaching you guys about plants, right? You've been learning all kinds of stuff about plants and what plants need to grow. What are some of the things that plants need to grow?
Water.
Sunlight, water,
Oil.
nutrients.
You forgot one.
Water. What about
Water.
space? Space, they need space to grow, right? Okay, well today we're going to be talking about one of those things. A specific part about the plants, though, it's about photosynthesis. Now that's a big word. I don't expect you to be able to spell it or really even use it in a sentence unless you're really into that sort of thing. But I happen to like science a lot. It was one of my favorite subjects in school. So first, I want to introduce myself. My name is Josh Rivers, and you guys have met me over the past few times I've been here, and you know that I've got two boys that go to this school.
And I know one of them.
And you know one of them.
Jacob Rivers.
The purpose of this lesson is to go into more detail about photosynthesis. Now, do you remember what photosynthesis is? How does it help a plant? But what about it specifically? It's because plants can make their own food. Very good. And they do that through the process of photosynthesis. Now, another big word that I don't expect you to know, but plants are what's known as photoautotrophs. That means that they make their own food using light. There's a special word for that. Photoautotrophs. But that's not a word you're expected to know yet. But I just thought it was kind of cool to tell you. So we've reviewed what we've already learned about plants, about how they need space and nutrients and soil and water and sunlight. So to introduce the topic to you, photosynthesis is the chemical process by which a plant takes energy from the sun and carbon dioxide, which is something that we breathe out when we breathe, and it turns those things into glucose, which is a sugar, or what we diabetics call a carbohydrate. And so by the term carbohydrate, you can break that term down like you can lots of scientific words. And you can break it down into carbo, which means having to do with carbon, which our bodies are made of a lot of carbon. And hydrate, which is having to do with hydrogen. So what is water made of? Does anybody know the chemical symbol for water? What do people call water? What you got?
Some people call it liquid.
Well, liquid. Yeah, I know you've heard it on TV. H2O, right? H2O is water. That's the chemical name for water because it means there's 2 units of hydrogen and 1 unit of oxygen. So when plants bring in water, they're actually breaking that down into hydrogen and oxygen because at the end of photosynthesis, plants they bring in the carbon dioxide, which is where they get their carbo for their carbohydrates, and they bring in the water, which is where they get their hydrogen for the carbohydrates, and they release oxygen into the air. And what do we breathe?
Oxygen.
Oxygen, right. We need that for our cells. Okay, so that's kind of the brief outline of the entire process of photosynthesis, but we want to go into a little more detail. So I have some terms down here at the bottom of your handout. Photosynthesis is how plants make their own food so they can grow. It's written down at the bottom. Plants are alive, which means that they grow just like we do. They just don't move around a whole lot. We like to move around a little more. And just like us, they need nutrients. We need nutrients and vitamins in order to grow, right?
Yeah. Ooh.
Okay? And now I will say that I have a very limited time, so we can ask questions and stuff at the end, but not too many. But if you have more questions for me, if Miss Parsons says it's okay during centers or something, or in the lunch line, you can come ask me, but only when Miss Parsons says it's okay. Because I'm not here to distract you guys from what she's doing. Chlorophyll. Chlorophyll is what makes plants green, and they're specialized cells, and they're also the cells that turn the sunlight into the sugar. Now cells, who knows that we're all made of cells?
Really?
Who's heard that before? Inside of our body, we're made of billions and billions of cells. Well, everything that is alive is made of cells. And all cells have different purposes. We have cells that serve the purpose of our skin, our bones, our eyes, our brain. They're all special kinds of cells. Well, plants have special...
And mouth.
Lips.
Nose.
Plants have special kinds of cells too.
And lips.
And chlorophyll are some of those special kinds of cells that serve a special purpose. Now, what part of a plant is usually always green? The leaves. Very good. The leaves. Okay. And I also wanted to talk about carbon dioxide. What that means is it's one carbon molecule and two oxygen molecules. And that's what we breathe out when we're done breathing. And that's what plants kind of breathe in, if you want to call it breathing. And of course, oxygen, down at the bottom of the page, whenever you see it written down, it's written as O2. That's the oxygen we breathe in. That's two oxygen molecules. And a molecule is just a couple atoms put together, or a few atoms, whatever the case may be. Now, I wanted to go over the difference between what is alive and what isn't alive, because although all cells are made of atoms, not everything made of atoms is alive. Is a rock alive? No, because a rock is only made of atoms. They're not made of cells. Anything alive, the basic unit of life is cells. Okay, so how does light get to plants?
From the sun.
From the sun. Okay? The sun sends out photons. Now this is up at the top of your paper, this word that's in quotation marks. In the middle, the ones that I wrote out, photons, P-H-O-T-O-N-S. And that is actually what we call a particle of light. So those particles of light are coming from the sun 24 hours a day, 7 days a week. They're always coming to us. They start in the middle of the sun, then they come out, and then they're finally emitted and they get on their way to us. Did you know that even though that light travels at 629 miles per hour? Now to give you a little comparison, most of your cars, your moms and dads drive, hopefully on the highway, they're only going about 55 miles per hour. This is over 670 million miles per hour. But it takes about 8 minutes for one photon of light to get from the sun to the plant. So if the sun were to go out all of a sudden, we wouldn't know it for 8 minutes. It wouldn't be dark for 8 minutes even though the sun went out like that, because it takes that long for the light to get to us because the sun is so far away. So even traveling that fast, it takes 8 minutes to get here. So those photons that hit the leaves, they interact with the cells, the chlorophyll, and the chlorophyll goes through certain chemical changes and breaks that sunlight energy down into usable energy, and that's what they use to break down the chemicals that turn into what? What do plants use for energy?
Sunlight.
Well, what's the chemical that it makes that they use? We know it as sugar.
Nutrients.
We know it as sugar. It's written on your paper. Starts with a G. It's right under the
Green.
Glucose.
Blue.
Glucose is the sugar.
Glucose.
Remember?
Where's that at?
Right here on the picture.
Blue.
Glucose. Yeah. Glucose is just a fancy name for sugar. And what happens when you guys eat a bunch of sugar?
We get wild.
You get wild, you get energy. Okay, well, since plants can't move around, they use all that energy to grow. And that's why we have trees that are so big. Have you ever seen a picture of a redwood tree or a sequoia tree? Some of those trees are, the trunks are as wide as a school bus. That's how big they are. Just not as wide, I'm talking not as tall, but as wide. They're so big around. And because they get so much energy from their leaves, they're able to grow that big. So,
What are them trees called again?
and also, we're glad that plants grow for one more reason, and what is that?
Seed.
Well, anybody like lettuce on their hamburgers?
Yeah.
Anybody like to eat salads,
No.
mashed potatoes?
Oh.
What's some other vegetables? Carrots, peas, beans.
Peas.
We're glad that plants grow because you know what? We can eat them to give us
I
more
don't like peas.
nutrients and energy because our body uses those nutrients to make energy. Okay, so in conclusion, because I'm really limited on time, but where do plants get the light that they turn into sugar?
Sunlight.
Sunlight. How long does it take that sunlight to get here?
8 minutes.
8 minutes. Very good. You guys are listening. Awesome.
I'm the one that's in sunlight.
Let's see. And I just want to show you something about, let me check my time real quick. Yeah, I'm over. So I'm about 3 minutes over, but I want to thank you guys so much for being so polite and helping me teach my first little lesson. And it sounds like you guys learned a lot. It sounds like you remembered a lot of what Miss Parsons has already taught you.
I want some cat ears made like this. Cat
ears? Okay, but I want to thank you guys, and I especially want to thank Miss Parsons for allowing me to do this, because this is her class. You guys are her students, and she's been kind enough to let me be a part of your second grade experience, and I'm very glad. So thank you. You can keep your handouts, and let's have a good rest of the day.
Okay. Woo, that was